Hi, everyone, and welcome to Cassandra Lunch number 79. Sorry for the background music. My dog, or background noise, my dog must have liked the music. Today on Cassandra Lunch, Obi Anant is going to be, sorry if I mispronounced that. He's an engineer here at Anant, and he's going to be presenting on Cassandra API and Cosmos DB. The organizers for this event are Rahul Singh, Arpan Patel, and myself. And we're always looking for members, speakers, and sponsors. So if you or someone you know would be interested in attending this, speaking at this event, or even sponsoring this event, don't hesitate to reach out to one of us. Our emails are listed below. We are a part of a larger community. Data Community DC is a diverse and inclusive culture, and we encourage people of all races, genders, sexual orientation, and religions, and we expect respect to be given to the communities. You can find out more about Data Community DC at their blog, as well as a list of their upcoming events. And what we cover here is everything related to Cassandra. So this includes variations of Cassandra, such as Scylla or DataStax. Also the surrounding ecosystem, so Spark, Kafka, those sort of things. And if anyone is new and would like to introduce themselves, feel free to do so, and I'll give you time. However, I'm going to continue moving through the intro. Some group rules. If you have a question, please ask it. Be polite and courteous to others and share what you know. This is meant to be a discussion. Here at Anant, we deal with real-time data and analytics platforms. So Cassandra is definitely a tool that we use frequently. It's part of our day-to-day lives, and we're happy to kind of educate the rest of the public with these talks. DataStax is also a partner along with George Washington University. These are some other program and organizational sponsors. And if anyone has any jobs, meetups, or hackathons, feel free to use this as an opportunity to announce that. You can drop it in the chat, or if you unmute yourself, I can give you a platform for a moment. Anant is hiring for full or part-time positions at data platform operators, engineers, and architects. You can connect with us at careers.anant.us. And some upcoming Cassandra events, or just events in general, we have the sister lunch to this that takes place every Monday at the same time. And we're going to be having a guest speaker presenting on managed airflow on AWS. And in the following Cassandra Lunch, we're going to be going over how to use Cassandra for content management. All of our events are listed at anant.us/events, so you can check us out there, as well as our past events are listed there as well. Along with all the videos that we do are recorded and uploaded to our YouTube, and we're also streaming live to YouTube. So if you're there, thank you. Don't forget to like and subscribe. And definitely we have over, this is our 79th. We have over over 60 videos up on Cassandra, the Cassandra YouTube. Cassandra.Link should be your #1 resource for all information related to Cassandra. This is a hand-curated list of articles or group of articles, all surrounding Cassandra and Cassandra topics. Be sure to check this out if you're ever curious about something related to Cassandra, or just want to learn more about it in general. This should be your #1 resource. And with that, I will pass it off to Obi as soon as I can stop sharing my screen. There we go.
All right. Share my screen. We'll get started in just a second. All right, is that visible? Okay, as you heard, my name is Obi Anant. And just as a sort of note order, I prefer to take questions during the presentation in the chat. Today's topic is Cassandra API and Cosmos DB. And that actually requires a sort of definition of terms, because we're going to be using Cassandra API 2 ways in this presentation. So the first thing we're talking about is Cosmos DBs Cassandra API, which is generally how I will be talking about it. It is the sort of interaction layer for Cosmos DB that uses Cassandra protocol. And then the second is Cassandra API, which I will be mentioning just as Cassandra API, which is a previous project that we did creating REST APIs off of Astra, which we'll be working with in this presentation today to use with Cosmos DB instead. All right, so just first overview of Cosmos DB. It's a managed NoSQL database. It's part of Microsoft's Azure cloud offerings, which means it's managed and hosted. And yeah, technically it's a multi-model database rather than being specifically Cassandra protocol related or anything like that. It has a number of sort of backing models that you can interact with. But it does, no matter which mode you're using, it does share some traits with Cassandra, which are that they're both distributed. You can distribute Cosmos DB, well, you can have Microsoft distribute Cosmos DB globally for you, and you can set up globally distributed Cassandra clusters. And then they're both also horizontally scalable, which means they're scaled via the addition of more commodity hardware versus scaled via the replacement of current hardware with better versions.
Yeah,
and then Cosmos.
Yeah, I would just clarify that when they say it's multi-model, it's more that when you say you want a new instance of Cosmos, you choose what you're under. You choose your API.
Yes.
So
that's the next slide.
Okay, just because Cassandra is technically multi-model, and so is DataStax. But the difference is that you can write in one way and retrieve in another way. Whereas I think I just want to make sure we clarify what multi-model is. Yeah. Sorry.
Yeah, but we'll get to that. So Cosmos DB is used to back a number of other Microsoft offerings. So it's involved with Microsoft Office, especially the 365 version, and then Skype and Xbox. And this is their sort of logo. It's just and then, okay, so Cosmos DB's multi-model APIs. So generally what Cosmos DB does on the back end is it stores items in containers, but depending on what model API you choose, it maps other NoSQL or SQL like concepts onto those items and containers. So there's the base SQL API, as well as a MongoDB API, which acts as a document store. So if you remember our talk on different types of NoSQL databases, we talked about document storage, we talked about key value store, we talked about graph databases, all that sort of stuff. You can have Cosmos DB act as those different types of database as well. And then each API also allows connection via drivers native to the API's related technology. So when we get into the Cosmos DB Cassandra API, we're going to be talking about how it uses Cassandra protocol and how you can connect to it using the drivers that you would use to connect to Cassandra, and that sort of thing. And specifically the concept that the Cassandra API, Cosmos DB Cassandra API, maps onto its containers and items are tables as containers which hold rows, which is sort of how it is in Cassandra. Cassandra specifically, I believe, uses a column family format within that sort of like for the actual storage within that, but it's the same concept basically. Okay, so Cosmos DB and Cassandra. The Cosmos DB Cassandra API allows storage of data into Cosmos DB using Cassandra protocol. You can connect with your standard Cassandra drivers in all the different languages that they're available in. You can connect via cqlsh and open up your CQL shell for the Cosmos DB instance. And it's compatible with and also different from Azure managed instance for Apache Cassandra, which is just like it says, a hosted instance of Apache Cassandra in Azure Cloud. And you can use this to do sort of hybrid deployments where you have your on-premise Cassandra and you have your Azure hosted Cassandra, but you also have Azure Cosmos DB connected to them. So before we move on to the demo, we're going to go through this article, this piece of documentation, which is about the Cassandra features supported by Cosmos DBs Cassandra API. So like it says, it uses Cassandra protocol, compatible with Cassandra Query Language 3.11, and apparently backwards compatible. The Cassandra drivers that work with it, Java, C#, Node.js, Python, C++, basically all the ones that are made available. It can use basic, like all of the CQL data types, as well as functions specific to CQL, token functions, TTL, write time, you can get all those values as well. And then also the aggregate functions that are available in Cassandra, average count. When you're when you're using the Cosmos DB Cassandra API, you also get access to those, as well as the blob conversion functions for converting to binary blob or from binary blob into actual types. All of the UUID and time UUID functions, and then CQL commands as well. So not all of these are actually provided. Like for example, you can't alter your custom type, but you can, I believe, create a custom type. And then it also has access to lightweight transactions. So and then also the unique CQL commands, some of which are supported and some of which aren't, like CQL copy, not supported. But some of these various other commands are, as well as select JSON and insert JSON, which is good because the Cassandra API that we're going to be talking about a little bit later uses insert JSON to load data into previously Astra, soon to be Cosmos DB. And so having access to that is good. All right, we'll get started moving on to the demo now. The first thing we're going to do when we get started is go through their sort of quick start. I already have an Azure instance up. So we're just going to basically look at the code that they use to connect and run that on Gitpod. All right, so while it starts up, this is a decent time for questions if there are any.
In the Azure Portal, kind of features did you see, in terms of like data exploration?
Yeah, so they have this data explorer panel where you can, I don't believe there's anything actually in here right now because the data that I loaded in while exploring, I deleted because the quick start and then later the import portion of the Cassandra API will be loading data in. So we want to be able to tell when that happens. But you can explore your data. It shows like a table of nice. For your table and that layout.
Nice.
Yeah. All right. So the first thing we want to do actually is we're going to prove that we can connect with cqlsh. It will load. All right, we're going to copy the standalone cqlsh tar into Gitpod, which you can just get. You search standalone cqlsh and you get it from DataStax. This is the DDAC version, but I don't think it actually matters. All right, so untar that file, go into the directory, set up the SSL environment variables. These instructions are also on, they're part of the quick start, not the standalone cqlsh. It assumes that you're using something from an installation that's already on your machine. But you can just use the standalone SQL shell. So we start SQL shell. We use our unique host identifier, as well as the default Cosmos DB Cassandra API port. Our database user, you decide that during the setup of your cluster, and then the connection string that it gives as a password, and use SSL. So we can see that we have a key space here called test key space, which is the same as the one here that we can see in Data Explorer. And we could even, if we wanted to create a table, key space. And then we can go back to and reload the Data Explorer to see that it's created our table inside of that key space. There's no actual data here, so we'll be able to load anything, but it will at least tell you what your columns are. All right, so exiting SQL shell, going back to the main folder, we're going to get started with their quick start example. Make a directory for it to go in. And then we're going to git clone their repo. Into the directory. And then we're going to install some requirements. So the first one is that they recommend that you use Cassandra driver version 3.2. Which, if I remember correctly, takes a little while to install, and we can use that time to go look at their code. So they're loading in their configuration values here from config.py. We need to fill in username, password, and contact point. It has the port already assigned. then in their actual code, they import that config as well as the Cassandra driver and SSL libraries, the SSL, these same presets that we exported in order to use CQL shell. And all it does is it creates a session using all those configuration values. And then it creates a key space, creates a table, and inserts some data. And then it selects from that table and prints it to screen. And we're actually going to copy this same method of connection that they're using here with SSL and loading the data from a config Python file. And we're going to transplant it into the Cassandra API code, which we're going to be working with the Python API from that project. But they previously used Astra's Secure Connect bundle and the authentication methods for Astra, which were different. This old version of Cassandra driver is taking a while. Also, this is a good time for more questions if there are any, but I'm also going to use this time to set up the config file, including adding the extra the config values that are used in Cassandra API that are not used in the quick start.
Yeah, I have a question for the Cosmos UI. I know Astra has a built-in cqlsh terminal, and then right now you use the standalone version. Does the Cosmos have an ability for you to be able to pull up some kind of terminal within the UI?
Yeah, so I believe that was somewhere that you can have a hosted CQL shell. Let's see. It requires some more fiddling around in your Azure account. That's already enabled. No. Yeah, I need to enable it.
Okay. But you could build a CQL query, it looks like. It's pretty cool.
Yeah, you can even add in data with the form. There's a lot of tools available. All right, what are the other prereqs? Pre-table. Requests. And then we need SSL. Right. I believe there's still one line missing from the config file. All right, so all we added to the config file are the key space and table. They were part of the Astra.credentials. You would create a file in there with these values in. But since we're switching to loading our configs from this file anyway, I figured put them all in the same place. So make sure this is saved. And then there was a slight issue yesterday with line 23, which is that it tried to give the port in string form when you want it in int form. And with that, we can run the quick start. Creates the key space, creates a table, loads in a couple rows, selects all of them, and then selects with the ID. And then if we go into the Data Explorer, we can now see the uProfiles key space, our table user. Our data explorer will show us the data. So what we're going to do next is we're going to steal this config.py and we're going to load it into the places where we need it. If I were actually, updating this project, I would, make this a global sort of change. There would be one config.py and all of them would pull from it as needed. But in this case, it's easier to import from the same folder. So we just make a couple copies. All right. And also before we get started there, let's install the requirements. Because we are inside a couple folder layers. There we go. Make sure we got all our requirements later for hosting the Flask app. And let's get started with the import. All right, so the original file here is rest to astra.api. It used to pull from an existing REST. Well, these are all details that are in the presentation that we did on Cassandra API. But it used to pull from an existing REST API and upload into Astra. At some point, we just saved the data that it was pulling because it was pulling from the same place over and over again, and we didn't necessarily want people pulling from our APIs. So we uploaded a bunch of that data into a JSON file, which the importer now pulls from. So the first thing we want to do here is we want to make sure that we have the new imports that we need, which are all the SSL stuff, environment variables, and then also the config file. And then this is where the connection to Astra usually was created. And we're going to replace that with the same one from
the idea.
Okay, someone just unmuted on accident. All right, moving on. And then we need to replace all of the previous references to the credentials file to make sure they're updated to pull from config. And then one thing that we're going to do, because this has not been updated in a while and is a little bit broken, is that before we try actually uploading them into Cosmos DB, we're going to do a little cleanup, partially because the text sections are very long, but it has problems with the way that the things like dates and Booleans are currently stored. So all we're going to do is just set them to constant values that the thing will read without problem. I think it's an issue either with the Python versions or the driver versions that it wants different types of strings in order to transform them into different types. The insert into JSON function probably is slightly different. So we do that, and then did I save this? Sure. Import. Oh wait, that wasn't the issue. It was because that's Python 2. All right, so it's just the same thing that normally does. And then we can once again go into the Data Explorer to make sure that our data is actually showed up. In this case, it's the same test key space that I left up from earlier, but instead, it has a schema similar to what we use to manage stuff for leaves. Only we have all our fields. And how much did this upload? Yeah, it's only set to 10. I believe we can go a bit harder.
So Obi, apart from the CQL layer, does Cosmos have any type of REST or GraphQL layer, or is it just pure native CQL?
Yeah, I think it's just CQL for this. I was never able to find anything on a sort of native REST API.
Gotcha.
Or something like Astra Stargate or anything like that. That would just sort of let you.
Right, right. And I think I had read before that they have some sort of consistency levels. They're not exactly the same, but
Yes.
but they're similar. But I guess it's more for the general design of it being like.
Yeah, their consistency is not the same. Here we go. Yeah, so Cosmos DBs consistency mappings are slightly different. They have to do with regions and strong or eventual consistency. So you're not getting the same local one, local quorum, all options, but you do have ways to mess around with your read consistency. All right. So the only thing left to do now is start our Flask app.
I think your app is your API is still talking to the.
Oh yeah, we did modify it. So here's the file. Like before, what we need to do is make sure that we've got all our new imports, the configuration, the SSL stuff, the environment variables, and then go down to where the connection to the Astra cluster is created and replace it with one that connects to Cosmos DB instead. And I believe this would probably have the same issues if you were doing inserts with the, yeah, since it's using the same insert into code as the other one. If you formatted your data the same way to present to the API, you would run into the issues with formatting.
You may have to do a search and
Yeah,
replace.
this again. Using it in a lot more places in this file because every time you go to the external database, you have to use the key space and table names, which were previously in the other config file.
It should expose the port when it comes up. There it is. Yeah.
You could also just copy the URL that you have for your container and then just add the 8,000 in front of it. So in like a new tab. And then just add 8,000 hyphen at the very beginning after each TTPS. Yeah. And then just put the REST endpoint at the end.
And we have our data. Let's see if we can get a single to look at.
Looking for an item ID. Yeah. 13940.
Yeah, so when I was messing around with this to get this demo ready, I removed content and content text and all, so that I would have an easier time parsing. Like the remainder of the JSON is fine, but you get these huge blocks of text because we were scraping entire web pages to work with for this data.
Nice.
All right, that is about all that I had for today. So if there are more questions about Cosmos DB or about, you know.
Yeah, I did want to comment. One of the things, in fact, I think Obi, you've played with some of the code because I'd given you a task to like delete some data. That original code came from a Cosmos DB tutorial. So, you know, no, regardless, like if you have to delete data in Cosmos, just like in Astra or Cassandra or DataStax, well, in DataStax, it'll be different because it has, you know, better indexing. And even, I guess, you still have to do the you know, the find everything, filter it, and then delete it because there's no such thing as delete from, you know, where this condition is equal to X. But yeah, so you know, as this is probably your first kind of foray with Cosmos, what were your initial impressions as compared to, because you know, like it's almost like a one-to-one mapping between Astra and Cosmos, and like you literally took code that was working with Astra and you made some changes. Apart from that kind of code changes, which we saw you do, what was your kind of impression in terms of the ease of use? Because like in the portal in Azure, it's got a bunch of other bells and whistles, right? It's not just obviously. So what was your kind of general impression?
Yeah, so the quick start actually has some of the instructions necessary to set up a database for the first time. And without that, I feel like it would have taken a lot longer. There's a lot of, I guess just because it's a cloud platform, like they have all their options and they all put them together in one place. So navigating to figure out what it is that you actually want to be doing there is a little bit difficult without a guide. But once the deployment was set up, I think working with it was relatively easy. Even getting the like SQL shell to work was relatively easy. They had, instructions that they wanted you to be using a Windows cql.py file, but it's basically the same options that you would pass if you were using the script on a Linux or Unix or Mac machine.
I mean, cqlsh is basically a Python program anyway, so it's not.
Yeah.
It's not like there's anything majorly different going on. What other differences or similarities did you see apart from the fact that it's like it's an API? Were there any features that you were like, oh, this isn't exactly the same?
Not really with any of the basic stuff. Interactions via CQL are all the same.
Does it have things like materialized views or secondary indices?
I believe it does have secondary indices. I don't know about materialized views.
Gotcha. Or like a SASE index?
I don't know about those specific types of secondary indexes as well. But it says Cassandra API supports secondary indexes on all data types except frozen collection types, decimal, and variant types.
Yeah. Okay.
So you can create your secondary index, but I'm not sure what it's actually doing there under the hood, especially since Cosmos DB is supposed to have some sort of special indexing property that's different from how Cassandra does indexing.
Great. Anybody else have questions? I have a few other questions and generally would ask the same thing if, doesn't really matter for me. Like, I'm just trying to get a better scope of it. Does anybody else have any other questions? I'm curious if there was, yeah, go ahead. It looks like Aaron's going to ask a question.
Oh yeah, I was just curious what you noticed about the performance specifically. Running a lot of those same queries against Astra, and then of course running them against Azure or on Cosmos DB. What did you see in terms of performance?
I don't know if I was doing enough to see real differences, because the only thing we were loading in was a couple, maybe 1,000 or a couple thousand rows into the table using the importer. And their quick start example has like 8 rows. So there's not an apparent difference from working with it doing just the basics.
Sure, with just a small amount of rows. Okay, all right, that's fair.
Yeah, I think, Aaron, I've read somewhere, maybe we have to verify that independently, but since Cosmos is a, completely global, multi-tenant, infinitely multi-tenant system, there's going to be slower in some cases, but in relationship to, let's say, Cassandra or DataStax or Astra, I feel like when you have a dedicated instance from somewhere, it's always good. That's always going to be faster. But it is, right. Yeah, it is something that you have to kind of see at which point you get a return on investment. But I think the biggest use case I've seen of it was they talked about it, so I can talk about it. They talked about it at one of those Azure days. But Carmex was basically using Cosmos as a reverse index to store pre-populated data. And they weren't using it for the actual transactions. They were just kind of shoving data into partitions and pulling it for, if you have a particular preference for a car, right? They would calculate that in the back end. They would shove it into a partition. So the next time you refresh your page, you would get your listing of stuff that you may be interested in. And they said that, for that purpose of it's not low latency. It's not like microsecond latency. It's just, you dump it and you get it, a bunch of information. It worked fine for that.
Okay.
Yeah. It is one of those things where when I first saw it, I was like, oh, so they're running DataStax in the cloud because it has Gremlin,
Right.
But that's not the case. It's very specific. And Eric is not on, but Eric works with Sitecore. And so a lot of the Sitecore is a customer experience management system. And they've gone back and forth between using SQL Server and Mongo or whatever. Their kind of like cloud offering is basically Cosmos because it has that Mongo layer to it.
Sure.
And I had considered, okay, so let's say if the data goes in via Mongo layer, can we run some Spark Cassandra queries on it? And of course, there's no bridge, right? So it's just
right. Okay. Yeah, Raul, I don't know if you have enough laptops there, bud. Wow, that's
you don't know. That's not the half of it. I just replaced. This is one half of it. The other half of it is over here.
Yeah, what monitors is he looking at right now? I'm sure there's at least 4.
I reduced from 12 screens to 8 because I got rid of old monitors.
Oh, so, sure.
Because there was an amazing sale on Black Friday.
That's awesome.
Yeah, maybe I'll do one of those YouTube Dream Desktop videos and show it off. No, I'm still getting used to, so I have like 2 32-inch screens here, and that's another one here. And I'm still getting used to, oh my God, my diagrams can be zoomed in, Lots of people get, they geek out about screens because of like how well Excel works in it. I geek out about screens about how well Visio or Lucid Draw works on it, Awesome. Very cool. Anybody else? Any questions?
Yeah, I had one question regarding like I guess UI, but Cosmos in general. Like, did you come across any limitations in terms of like, do they have preset limits on obviously discounting or like taking data model design out of the question, but like, do they have limits in terms of like the number of key spaces you could have for an instance or like tables or stuff like that? Or is it kind of just do what you want, pay for what you're using? Or it would be like viable to have like, depending on your data model, kind of in a Cassandra multi-cluster, you could have multiple Cosmos DB Cassandra instances, if that makes sense.
Well, I think mostly it's the sort of second thing you mentioned, where you pay as you use it. So if you set up more key spaces, well, if you end up using more computation and more storage, then they will charge you more for it. But as for limits, I believe the ones that they talk about for the Cassandra API are like similar to the ones that we talk about for actually using Cassandra, where you want to limit your partition size, and how much data can you store inside a single entity in a row, and that sort of thing, where you're looking at how much data you're storing in these sort of smaller units, but you can have as many of them as you want.
So would it like block you if you started to put more rows into a partition if it were to exceed a particular size?
I don't know. It says should not exceed. So it sounds like no, they won't stop you. But I don't know for sure.
Yeah, their pricing, ARPA, and I also kind of like, I had to evaluate Cosmos against DataStax Enterprise, and we went with DataStax Enterprise because of the real multi-model, but the costs in Azure Cosmos DB, the higher costs usually come from wanting to do analytics on that data. The read and write is it's whatever, but they have a different tier for pricing for doing analytics that makes it a little bit more affordable. But I think what could be a future test is to do a real benchmark in terms of data read and write from a transactional perspective, but then also do like a Spark application crunching it to see how those costs go up. But yeah, that's the one thing that like, it's a cool product. I wish it had integration in itself. Like I wish it just had
if the model APIs were connected, it would be like the most amazing thing.
The other thing I know is hard is and I wish, and I think like in the Azure world, they have like, Dynamo connected to whatever, you can do Dynamo streams connected to, Amazon search or Elasticsearch or whatever to like look at that data. And, in Astra, I think upcoming, it's already there. It's like you can use Pulsar streams to kind of connect, but I don't know if there's a very specific like indexing. That was the question I was going to ask. If there's any specific indexing roadmap of like, if you were putting all this data and you wanted to do a full text index, is there like a button you push, or do you have to then create a cognitive search instance and then connect it using some other way? So no answer means there's no answer, huh?
Yeah, I'm definitely not sure of that.
Yeah, that's the thing that I saw, was that the search, doing any type of search with Cosmos was a similar challenge that we have with Cassandra or Astra. For the full text search, you still have to put it somewhere else. I think it doesn't have that built into it. Awesome.
One more question for me. Is there like I'm not super, it's been a while since I looked at the Cosmos dashboard. Like, is there like a way for like a one-click integration to hook up? Say you already have a Azure Databricks account, like is there a way to like connect it directly to Cosmos that way, like within the dashboard? So you don't have to do it via connection strings and credentials in your potentially your whatever cluster you have running in Databricks.
Peter sent a link. Nice. Yeah, I would hope so, Arpan, because Azure has a Databricks offering that competes with its own kind of HD Insight offering for Spark, and then they have something called Synapse. I did see a one-click for Synapse, but I didn't see it for Azure. Hope that answers the question.
Yeah, so I haven't validated whether that's for CQL, but they do have a change feed, they call it, for kind of a CDC-like feature. But again, your mileage may vary. I just found that link. I haven't validated anything.
Yeah, I think it's using their internal queuing engine, maybe.
Yeah, I don't know.
And then the example shows like you have to have a serverless function basically to kind of manage your whatever you want to do with that feed. And then the code is C#.
Mm-hmm. So this is kind of like a higher level question, but I noticed that, for instance, Microsoft also now offers like a managed Cassandra service. So I was wondering if they're trying to move users to just like actual Cassandra as opposed to doing the Cosmos DB interface. Do you guys have, when you're doing research, did you find anything like that? And, whether they're steering folks to actual regular Cassandra?
Yeah, it's a good question, Peter. And when it first came out, I think it's called Managed Instance for Apache Cassandra. What my understanding is that is the gate which they want people to first connect to from their existing Cassandra, right? Like you can have your own Cassandra on AWS or Azure VMs or whatever it is. And then once it connects to that managed instance for Apache Cassandra, that is technically, it's kind of like a data center in your cluster.
Yeah.
Then that data can have a potential bi-directional sync with Cosmos DB. But I haven't proven it. I just read about it. And so, yeah, so I think it's a tool to bring people into the Azure ecosystem and then see if Cosmos works, or just use managed instance for Apache Cassandra because people are more familiar with it, right? It's the same thing, but it's being managed by them. I think that's the game plan. Probably because I think they probably came up with it from a product perspective because it's like, hey, I've been using Cassandra. Not everything I'm doing is working in here, right? There's probably a list of features that is not in Cosmos that is in Cassandra.
Yeah. Well, people don't want to discover that as they're migrating.
Exactly. Well, and you know what? That's the thing. When I was evaluating Cosmos against data stacks, the strategic direction from the CTO or the CIO of this like massive company was, oh, everything needs to be Azure. And so when we were like, well, Cosmos DB is not going to cut it, and they were like, why? It's like, well, it's not just that, if you move stuff from, well, in this case, it was data stacks. It was like, we were using all the different workloads, right? Like Spark, which could be moved over to Databricks, Solar, Gremlin, and actually we were using, DSCFS a lot. And so that could be moved to Azure Data Lake. It was like the moment we told them that there were like 5 different things that would have to be moved over one by one, they're like, oh, okay, we get it. So I think it was one of those things where if people are making a new application and they're already kind of hook, line, and sinker in the Azure space, they can say, okay, I can try it out. But if you have to move an existing like business critical application, there's a lot of work involved to make it work with Cosmos. That's what I saw. And that's the reason why I didn't recommend it for that one particular use case. It was just like, hey, this is completely, it's not the same thing, basically. It's not an apples to apples.
Got it.
Yeah. Cool. Well, I think we are at time. Thank you, Obi, for good view. Like to get objective, viewpoints on technologies related to Cassandra, and thank you for showing that it's Cassandra-like, and making it work with the code. I think that was great. Good hands-on stuff.
Yeah, nice job, Obi.
Thanks.
All right, see you guys soon. Have a wonderful week. See you next time, same place, same time, same place.